PQRS is a quadrilateral with PS parallel to QR. So in other words, what we have here is a trapezium. The perimeter of PQRS, so that's the distance all the way around this, is 3 meters. The length of PQ is 1, as shown in the diagram. The length of PS is x, and the point T is on QR such that ST is parallel to PQ. In other words, this distance here is also x. And of course, this distance here is also 1. In other words, we've got a rectangle there. The PSTQ is a rectangle. Angle SRT is theta radians. Find an expression in terms of x for theta. Well, if this is 1, so if this is theta, this is the right angle, then in this one is the opposite, this is the adjacent, and this is the hypotenuse. So tan of theta is equal to the opposite, which is 1 over the adjacent, which I've just called A here. And so A is going to be 1 over tan theta. So that's that distance just there. Sine theta is going to be the opposite, which is 1 over the hypotenuse, which here I've called h. And that gives me h is 1 over sine theta. So the perimeter, which we know is 3, is going to be, let's start here, x plus 1 plus x. So that's 2x plus 1. Add the a, which is 1 over tan theta. Add the h, which is 1 over sine theta. So that means that 2x is going to be, so if the 1 goes over there, that 3 take away 1 is 2. Take away 1 over tan theta. Take away 1 over sine theta. So x is going to be 1. Take away 1 over 2 tan theta. Take away 1 over 2 sine theta. And there are other equivalent expressions that you could have got to there. And we may need to work a bit with this trigonometrically in order to get the answer to the next bit. So show the area of this is given by A is equal to 1 minus cosec theta over 2. Or the area, so PQRS, the whole thing, we could deal with it as a trapezium, but it might be slightly better as a rectangle and a triangle. So the area is going to be, the area of the rectangle is just 1 by x, so that's x. And the area of the triangle is going to be a half of the base times the height. So that's going to be a half times a, which we know is 1 over tan theta, times the height, which is just 1. So that is going to be x plus 1 over 2 tan theta. Now the x from up there is 1 take away 1 over 2 tan theta, take away 1 over 2 sine theta, but now we're adding 1 over 2 tan theta. So those will cancel, and we have 1 take away 1 over 2 sine theta, and of course cosec theta is 1 over sine theta. So that is just 1 take away cosec theta over 2 as required. Hence find the exact value of theta when A is 1 minus root 3 over 3. So what we have is 1 take away root 3 over 3 is equal to 1 take away cosec theta over 2. So well, the 1's will cancel, and so we'll have minus root 3 over 3 equals minus cosec theta over 2. So that's just the same as saying cosec theta over 2 equals root 3 on 3. And so cosec theta is 2 root 3 on 3, which we could write as 2 over root 3, which means that sine theta is root 3 on 2, and that's a standard angle, and we should know it, and that means that theta is, what did we work in? We're working in radians? Yeah, we're working in radians. So that would be pi by 3.